Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll evaluate limit of piecewise functions. As per the problem, determine the indicated limit if it exists. And we are given these four piecewise functions. A piecewise function is a function which is made up of different functions over its domain. We have to evaluate the limit for these functions. Let's start with part A. For part A, we have to calculate the limit x approaches -1 for f at x, and function f at x is made up of two functions x plus 2 for domain x is less than -1 and -x plus 2 for x greater than or equal to -1. Limit of a function exists if the left-hand limit is equal to the right-hand limit. There is a very important concept we need to understand and memorize. We have to calculate the left-hand limit and the right-hand limit for this piecewise function in part A for x approaches -1. Let's start by calculating the left-hand limit. For left-hand limit, we put a small negative sign on -1 to show that we are approaching -1 from the left side. For the left-hand limit, we should use the function x plus 2 because the domain for this function is x is less than -1. Since we are approaching -1 from the left side, we should use the function equation as x plus 2. We can evaluate this left-hand limit by subbing in x as -1. I get 1. Now we have to calculate the right-hand limit. For right-hand limit, we put a small positive sign on -1. For right-hand limit, we should use the function -x plus 2 because for this function, the domain is x is greater than or equal to -1. We should sub in x as -1. The right-hand limit is equal to 3. Since the left-hand limit is not equal to the right-hand limit, we can conclude that limit x approaches -1 for f at x does not exist or DNE because the left-hand limit is not equal to the right-hand limit. This is a very important concept we need to understand and memorize. Now we can analyze part B. In part B, we have to evaluate the limit x approaches 2 for f at x. The piecewise function in part B is made up of functions -x plus 4 for x less than or equal to 2 and -2x plus 6 for x greater than 2. Let's start with the left-hand limit. We put a small negative sign on 2. We use the function -x plus 4 because for this function the domain is less than or equal to 2. We should sub in x as 2. I get 2. The left-hand limit is equal to 2. Now we can calculate the right-hand limit. We put a small plus sign on 2. For the right-hand limit, we should use the function -2x plus 6 because for this function, The domain is x is greater than 2. Now we can apply the limit. We should sub in x as 2. I get 2. The right hand limit is equal to 2. Since the left hand limit is equal to right hand limit, for part B, we can conclude that limit x approaches 2 for f at x is equal to 2. This should be the final answer for part B. Now we can analyze part C. In part C, we have to calculate limit x approaches 1 over 2 for f at x. The function in part C is a piecewise function. It is made up of functions 4x for x greater than or equal to half and 1 over x for x less than half. Let's start by calculating the left hand limit. For left hand limit, we should put a small negative sign on 1 over 2. We should use the function 1 over x for the left hand limit because for 1 over x the domain is x is less than 1 over 2. Now we can apply the limit. We should sub in x as 1 over 2. We can write this expression as a division statement, 1 divided by 1 over 2. Next we can change it into a multiplication statement. We can flip the fraction 1 over 2 to 2 over 1. 1 times 2 over 1 is equal to 2. So the value of the left hand limit is 2. Now we can find the right hand limit. For right hand limit, we can put a small plus sign on 1 over 2. For right hand limit, we should use the function 4x because the domain for 4x is x is greater than or equal to 1 over 2. Now we can apply the limit. We should sub in x as 1 over 2. 4 times half is equal to 2. The value of the right hand limit is 2. Since the left hand limit is equal to the right hand limit, therefore the value of the limit x approaches half for f at x is 2. This is a very important concept we need to understand and memorize. Now we can analyze part D. In part D, we have to evaluate limit x approaches negative 0.5 for f at x. The function in part D is a piecewise function. It is made up of functions 1 for x less than negative 0.5 and x squared minus 0.25 for x greater than or equal to negative 0.5. Let's start by evaluating the left hand limit. We should put a small negative sign on negative 0.5. For left hand limit, we should use the function 1 because for this function x is less than negative 0.5. Since there is no x term in this function, the value of the left hand limit is equal to 1. Now we can find the value of the right hand limit. We should put a small plus sign on negative 0.5. For the right hand limit, we should use the function x squared minus 0.25. Now we can apply the limit. We should sub in x as negative 0.5. Negative 0.5 square is equal to positive 0.25. I get 0. Therefore, the right hand limit is equal to 0. Since the left hand limit is not equal to the right hand limit, this means the limit x approaches negative 0.5 for f at x does not exist. We can write the answer the same way for part A. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.